Find the absolute maximum and absolute minimum value of this function h of x. But let's rewrite this first. Because of that fraction part, I'm not liking that very much. I would like to rewrite it into this form. Write the 16, and instead of over x, write it as x to the negative first power. So this way, we can just use the power rule instead of the quotient rule. All right, we're ready to find the derivative for the critical values. So derivative of x is 1. Oopsies. And let's work with the second term. If I find the derivative of 16 times x to the negative first power, I have to multiply those two yellow underlined numbers. That's going to give me negative 16. And the exponent will go down to negative 2. Now, let's talk about the critical value for this. This is a rational function. Okay, so remember for the previous ones, we had to just set this derivative equal to 0 because polynomials, they're always defined, okay? But for rational functions, we also need to consider when this function is undefined, okay? So, well, let's do what we are good at first. Let's set this equal to 0 first, okay? So I'm going to say 0 equals 1 minus. And for me, I think it will be easier if I put this back in a fraction form. So look how I rewrite this right here. Okay, I can write the whole thing the same, but I'm going to write it as 16 over x to the what power? Positive second power. And I'm going to solve this equation to find that first critical value. Okay, I can see different ways of doing this, but the most efficient way that I'm seeing is this. Move this to the other side. If you move that fraction that's negative to the left side, we're going to get positive 16 because I'm adding it to move it to the other side equals 1. Look at this equation for me, okay? You got a fraction equals 1. When is a fraction equal to 1? Well, you have to have 16 divided by 16 for it to be equal to 1, right? Because anything divided by itself is equal to 1. If it's anything other than 16, that's not going to be 1. So what I know from this equation is that x squared better be equal to what number? 16. And I can get the same answer by multiplying both sides by x squared. That works, right? If you do that, then you get 16 equals 1 times x squared, which is just x squared. All right, so let's solve this. What's the answer, guys? I know you know it's 4, but also negative 4 also works, right? Because it can be both positive 4. I mean, 4 squared is 16, but it's also negative 4 squared equals 16. And when you take square root of both sides, or even root, like 4th root, 6th root, 8th root, you always have to put plus or minus sign. So we have two critical values. I'm going to circle these, okay? Now we also need to consider when this function is undefined, okay? Because critical values happen when the derivative is equal to 0, and it also happens when the derivative is undefined. And for the polynomial cases, we didn't really have to consider those because polynomial functions are always defined. But you know, fractions are a little different, right? Fractions are undefined when the bottom of the fraction is 0. So write this down with me. You have a question. When is h prime undefined? Okay, when is this derivative undefined? One's not really going to do anything, but look at this fraction for me. This fraction will be undefined when the denominator is equal to 0, right? So h prime is undefined when h squared is equal to 0, okay? Because that's that trouble. That's that fraction part that can make this undefined. So we're going to solve for the x value here. X squared is equal to 0 and x is equal to 0. So I feel like we got so many values to check. But let's go back and look at that interval here, okay? They gave us an interval from 4 to 20. So I don't have to check anything that is outside this interval, okay? So we're only checking numbers that are from +4 to 20. So look at this, all these numbers that we found. Look, x equals 0 is a critical value, all right, but is it in this interval? Is it bigger than 4 but smaller than 20? No. So I don't really have to check this, okay? It is a critical value, but not for this particular problem over this interval. Now, what about 4? Yeah, we got to check that one. That, when they drew this square bracket, and that is an endpoint, so we have to check it. But what about -4? Do I have to check -4? Not really, because -4 is not even over this interval. So I'm like, we did all this hard work, but nothing really comes out of this work, right? That's kind of sad. But let's go ahead and plug in the values. And it looks like I only need to plug in +4 and 20. All right, so if I plug in 4, I'm going to get 4 plus 16/4. That is 4 plus 4, that's 8. If I plug in 20, I get 20 plus 16/20, and that's 20 plus 4/5, 20 and 4/5. Well, remember, we never really use mixed numbers anymore in math, right? So let's try to write this as a improper fraction, okay? 20 times 5 is 100, and 100 plus 4 is 104. So, all right, so we got these numbers. Which one is bigger? 20 is bigger than 8. So this gotta be the maximum. This is the maximum value, and this is the minimum value. Okay, so absolute maximum value is 104/5, and that happens at x value of 20. The absolute minimum value is 8, and that happens at the x value of 4. I never really checked it because all these other problems, I don't know, I just did it and I felt like, all right, those were easy. But this one, I kind of want to check the answer with you, and I want to show you how you can do that on a graphing calculator, okay? So I'll open up a graphing calculator right here, and I will type in that function, h of x equals x plus 16/x, okay? And we're not checking everywhere. I'm just going to bound this domain because the smallest number that I was going to check is 4. So left endpoint is 4. I want x's to be bigger than 4, but I want all my x's to be smaller than 20. So when I restricted the domain, they show me this noodle. Okay, look at this graph. Okay, let's see. What is the highest point of this graph? 20 and, I'm sorry, 20.8 is the highest point, but that happens at 20. I had a fraction, so I want to make sure that matches that decimal. 104 divided by 5. Remember, that's my value, right? Oh yeah, and they are the same. So we got the absolute maximum right. That happened at x equals 20, and the highest value this function reached was 20.8. Now let's go to the lowest value. Whee! The lowest value is 8, okay? And that's my absolute minimum right there, right? And that happened at the x value of 4. So if you guys want to do this work using calculus but still want to check your answer, I think graphing calculator will be great. But this one was a little bit more difficult because we had to check not only when the derivative is equal to 0, but also consider when is that derivative undefined for rational functions. And unfortunately, that x equals 0 wasn't used, right? It wasn't used over this interval. But if we were considering an interval from -4 to 0, oh, I'm sorry, that looks bad. Like, let's say, like, how about like 0 to 20, then, never mind. 0 is where the vertical asymptote happens for this case. So that wasn't going to be any max or minimum. They couldn't have done that because it was approaching positive infinity there. But this one was a little different. And I think the reason I put this question here was because I've seen a similar question on your MyLab homework. So you guys try it. This one was definitely more difficult than the first two that we did. Okay, but we just have one more, and I'm going to stop this video, but I'll come back and show you example 4 in another video.